2.5, wrapping up chapter 2, which has been quite long. Looking at measures of position. So we'll be looking at these guys. We'll look at the quartiles. Which are just quartiles are just almost like the median of the median, right? If you were to find the middle of the data, right, then on each side you find the middle of those sides, right? That's what quartiles are. What they do is they cut your data up into quarter chunks, right? You got a quarter of the data there, a quarter of the data. It chops up your data. If you were to list it in the same way as you list for a median, right, in order, you're just going to put 2 more points in between. Interquartile range is just a measure of spread. We'll make a Boston Whisper plot, which is probably where we're going to spend a majority of our time. We'll look at percentiles, not hard. And then we'll look at a standardized score, or a z-score, which just involves plugging stuff into a formula and interpreting. It's not going to be that bad. This is not super bad. There are a lot of words in here that look nasty. Don't get caught up in that. It's actually fairly simple. I'll try to simplify it as much as I can for you guys. So, fractals, not like fractiles. Like not fractals, but fractiles. They're just dividing data into equal parts, right? So if I was going to go, so I could divide it into tenths, right? So I could do 10%, 20%, 30%, 40%, 50%, and just talk about that. That's called a decile, actually. Quartiles just go divided into 25%, 50%, 75%, 100%. No big deal. And for our first quartile, about 1/4 of the data are going to fall on or below quartile 1, right? So that encompasses 1/4 of the data, 1/2 of the data, quartile 2, and then quartile 3 is 3/4 of the data below. I'll draw you a nice little picture back here. All right, hey, let's find the quartiles. I'm going to show you guys how to do this. All right, so we're just outside. We're not going to do this one quite yet. I would like to show you guys an example with a smaller data set, so that you can kind of get a better idea. So let's go ahead and actually start reading. What if I had a data set that looked like this? All right, and this was my data set. Whatever, so some numbers came out, right? If I wanted to find, it's in order, right? Already. So if I wanted to find the median, what would I do? I would find the center of it. How many other are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'll go to 6, right? And then find the middle one. 1, 2, 3, 4, 5, 6. Boom. There's my median, right? So now, in order to find quartile 1 and quartile 3, all I got to do is like find the median of what's over here, right? So I'm essentially finding the median of that and find the median of this, right? So I'll count it out. I go 1, 2, 3, 4, 5. Well, I can go in, right? So I know. So I have 2 middle values, right? We're counting it. Sorry, what? Sorry, yeah, we're counting in 10. I don't know why I didn't count the 10. So we're going to go boom. Oh, I didn't like that. Sorry, my board was not happy about that at all. So where's our middle one? Oh no, that's right. Okay, cool. So these are our two middle values, right? No, I don't know why I'm having a hard time counting this. Some reason, 7. Right? So that's the middle of these two, right? So this is quartile 1. And then we're going to count in, right? Boom. Boom. So 12 is quartile 3. So that's all it is, right? So I split it up into quarters, right? 8 to 6, right? I'll split this all up into quarters. Not too bad, right? All right, so I'm going to show you how to get your quartiles from data using your calculator, okay? So, I feel like I wish we had a smaller data set, but let's go ahead and enter these into the calculator. Remember how to do that? We are going to hit from your home button, you're going to make, right? So if you're home, you're going to make a new document. And then we're going to add Lesson spreadsheet. This is the 50 richest people again. So let's call it rich. You can call it whatever you want. And then we'll begin entering the data in this column. Here is the data. I know it's a lot. I wish we had a smaller data set, but it's okay for us to do this too. Yeah. Just make a new document. It'll work. All right, so you want to do it? Go for it. You can. It works just the same as your calculator. Yeah, go ahead. Yeah, go ahead. It's kind of. I think it's kind of fun to work with the calculator on the smartboard. Yep. 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 So follow along, guys. Doc, insert, calculator. It's the same process we've been going through.
Menu, stats,
You're going through?
Yep.
and then rich.
Click on the arrow. Yep. And there it is. Thanks. Awesome. So it's the same process we've been going through before, right? Except for now, we pretty much now use just about everything that we can spit out here from home variable stats. We have used mean. We have looked at standard deviation and SX. We used N. And now we've got quartiles. So Q1X, that's quartile 1, 54. Q3X, that's quartile 3, 78. Obviously, we know what max and min are. We actually have used this SSX as well, right? The sum of all the difference of x squared. We've pretty much used everything that's on this this output so far. Pretty good. Now that we've got quartile 1 and quartile 3. And then it was asked, hey, is quartile 2 always your median? Yes, it is. All right, let's get down to that. Cool. So now we can calculate this. We've calculated. We don't need to write this down necessarily. We got that. And we went ahead and used technology already to find our quartiles. We didn't actually come to a conclusion with this one, though. It doesn't say what can you conclude. So let's make a conclusion about the data that we got from or this output that we got from our calculator. How would we interpret quartile 1 in the context of these 50 richest people in the world, okay? So quartile 1 is 54. What does that mean? That means that a person, that the 54-year-old in this group, right, is richer than 25% of the 50 richest people in the world. Does that make sense? It's giving you what's called a percentile. So, a lot of times you see percentiles when you get your test score. So when you guys were little, right, and you guys were taking the NWEA, remember that test? Maybe not, right? You get measured using that test using percentiles. They'll say, hey, you're in the 73rd percentile. What does that mean? That means that of all the people that took the NWEA test, you scored better than 73%. So what it does is it gives you like a relative standing. It doesn't just give you a score, you got so much out of 100. It tells you, hey, compared to everybody else that took this test, this is how well you did. And that's really what we're looking at in this section. We're looking at like a relative standing. How did something perform or do, or where is it located in terms of a total data set? Not just a score, but how is it relative to everything else? So how do we interpret quartile 3 then? We would say a person in this list who is 78 years old is richer than 75%, right? Since it's splitting it up into quarters, right? A quarter of the people are less than quartile 1. Half of the people are less than the median, and 3/4 are going to be less than quartile 3. So that's the way we're looking at stuff. We're looking at it a relative standing. Okay. We're not using these calculators. All right, interquartile range is the difference between the third and first quartiles. So you're essentially looking at that middle range. So in the case of our 50 richest people, our IQR, or interquartile range, is going to be, what did we say quartile 3 was? 78. Quartile 1 was 54. So it's going to be 78 minus 54 for 50 richest people. Plus U. So the interquartile range is 24. All right, we did it. We found the interquartile range. Awesome. Okay, here we go. How many of you remember making a box and whisker plot? You have done it at some point in time. I promise you, at some point in time you've done it. I've raised 2 kids through elementary school, and they did it at some point in time in their elementary school career. Okay. Hey, also, guys, when I talk about this, I'm gonna call it a box plot. Okay. You can also call it a box plot, and it's so much easier to say. And whiskers remind me of cats, and I don't like cats, so
I hate cats.
So we're gonna call it a box plot.
Of the earth.
Yeah, strangest creatures on the planet, seriously. they're weird. The Komodo dragon is just gross. It's not weird. We still have 6 minutes, so don't mind the clock that's off there. So this is what it's going to look like. Okay, you're going to have a plot. You're going to put some sort of a label, right, down here on this axis, right? You're going to have some number values here. You have to figure out a scale, right there. Okay. You're going to have a minimum entry. It's going to look like that. So your minimum is going to be right there. Then you're going to have a line, a longer line, okay? A longer line. This longer line always represents quartile 1. You'll attach your minimum entry and your line that you made for quartile 1. You'll make another line. This line is going to represent your median. Okay? We'll go ahead and connect the tops of those. Their second to last line you'll have, and they're not always going to be even, right? So it might be over here, right? This line represents quartile 3. We'll connect that. There's your box. You just made the box. And then you'll have some maximum value here, and you'll connect them. So this one right here is your max. Okay. Now this is the only thing that's weird about this is this might not always, your max might not always be a line like this. It might turn out that you have an outlier. And if you do have an outlier, right, again, that's still your max. Sorry. If you have an outlier, and actually just keep it like this for now, but if you have an outlier, it's going to be represented as a dot that's separate. Okay? That's the way your calculator is going to output that. So we'll be aware of that. For now, we'll leave this picture this way. Yeah.
How far apart does the outlier have to be from the rest of the status set?
That is a great question. There's actually a formula for it. It's I'll answer your question and then we'll go into more detail with the answer. But any data point that is 1.5 times your IQR above quartile 3, that is an outlier. Anything that is 1.5 times your quartile 1, times your interquartile range below quartile 1 is also an outlier. I'm going to show you an easy way to calculate that, and also your calculator. If there are outliers in a data set, when we make it do a box plot, it's going to spit that out for you. You're going to be able to get that value straight away.
So we do it after, we times it after quarter 3 because the outlier is in quarter 4?
Yeah, the outlier will be in quartile 4. Exactly. Yeah. Totally. It'll be, an outlier will be above quartile. Yeah. Cool. And the next thing we're going to do is construct one of these. We'll start off next class by making a box plot. And we're going to do a box plot of this rich data. So if you will, please, the document that you just made, will you please save it as rich so that we don't have to re-enter it? That'll be on these calculators, okay? I'll show you how to save it. So I believe you can hit doc, file, save as. And then you're going to name it rich and save it, okay guys? That way we don't have to go through this process of entering it as we make a box plot for this data.